So this is an initiative by the Himalayan Water Network in collaboration with the IMI program. So just a bit of introduction into why and everything. So over billion people depend on the Himalayan region, where a lot of rivers, million springs, aquifers weave through vast landscapes to support a lot of communities, economies, and ecosystems. So this region is central to water security, climate resilience, and ecological health for much of South Asia and beyond. So yet it is a bit of at a crossroads, facing a lot of socioeconomic challenges. Environmental disturbances fueled by growing population growth, resource depletion, unplanned urbanization, poor development, and a lot of governance challenges too. So, the Himalayan Water Network, which is a consortium of researchers, civil society actors that have been working in this region for several decades, is collaborating with the IMI program to convene a dialogue around water, livelihoods, and development challenges in the Himalayas in the form of this webinar. So, the objective is to foster dialogue among key stakeholders to promote cross learning and to promote researchers and practitioners to form a community of learning and practice. So, today's session we launch with a broad overview, setting the thematic context for the coming weeks. We'll today explore how springs, aquifers, downstream plains, and forests interconnect across the region. And the presentation by Dr. Rajesh Tarani unpacks these linkages. And this will set the stage for critical conversation in the coming weeks around springs revival, urban rural water management, and climate induced disasters and consequences on unplanned urbanization and so on. So yeah, over to Urna now to formally introduce our speakers and discussants.
Thanks, Priyanka. Hi, everybody. Thank you so much for joining. I'm just going to quickly give you an introduction to our very esteemed panelists. So we're going to have our primary speaker will be Dr. Rajesh Thadani, who's an ecologist with a PhD in forest ecology and physiology from the Yale School of Environment. He's an expert on forest ecosystems in the mid-elevational Himalayas. He's also the founder of CEDAR and chair of Himmothan NIDA and the Kumaon Gramin Udyog, which are development sector organizations working on livelihoods and environment across various Himalayan states. And he's also president of Jai Hind College in Mumbai. Our discussants are also people who are doyens of work in mountain ecosystems. So we have Dr. Himanshu Kulkarni, who's a leading hydrogeologist and co-founder of Aquadam. Dr. Kulkarni has pioneered the practice of hydrogeology-based spring shed management through active community participation. His work on mountain aquifers has influenced spring recharge initiatives across states and organizations, and he too contributes to numerous educational institutions such as TIS and Shiv Nadar, and has held many advisory positions in government committees. Lastly, we have Dr. Ravi Chopra, who's an eminent environmentalist from Uttarakhand. He's the founder of the People's Science Institute, a nonprofit known for also its innovative and really pioneering work in water management, disasters, as well as environmental quality monitoring. As a researcher, his work has focused on technology, environment, and development. And in his 4 decades of work, he has helped establish many organizations and been part also of several government committees. And lastly, early on in his career, Dr. Chopra helped produce the first Citizens Report on the state of India's environment in 1982, for which he received national recognition. So those are our esteemed speakers, and I hope, like Rajesh sir, you can add on in case I've missed anything. So yeah, I think, yes, Ravi sir.
I would like to add on one small comment. Himanshu Kulkarni has hidden himself, but those of you who don't know, he has recently received the International Water Prize for the fantastic work that he has done. Congratulations, Himanshu.
Thank you, Ravi. Thank you so much.
Okay, I think we can now, I'll pass it on to Rajesh sir to start his presentation.
Thank you, Urna. Thanks for that introduction. And yes, I think it's an honor to be here. Thank you to IMI for inviting me. And it's an honor to be sharing this platform with Ravi and Himanshu, both of whom, as you very correctly said, are doyens of the Himalayan environmental field. Himanshu it's not just the prizes of the International Water Prize, but, and I think I will refer to this during my talk, is the person who's really popularized the whole concept of Himalayan hydrogeology, of working with springs across the Himalayan arc, and something that was relatively unknown 20 years ago is now become commonplace knowledge, thanks to his efforts and the efforts of Aquadam. Ravi Saab, of course, has been working for the last 40 years and has done so much that if we start talking about it, I think it'll take much of the full hour. So maybe we'll leave that to the end. But I'll get started right away with the presentation. I know I'm on a short clock. Oops, I need to figure out a way to. Is that visible as a full screen?
Now it is, yes.
Okay, great. So again, thank you to IWMI and the IWMI Tata program for hosting and organizing this, and thanks to Urna, Priyanka, and Sangram, who've been very active involving this. Now, the IWMI takes a somewhat anthropocentric viewpoint for Himalayan waters. And within this also, there's a lot of different areas one can talk about, from water supply to livelihood enhancement to issues of governance. In my presentation today, I'm going to be focusing more on source sustainability, as the title would indicate. Springs, as we all know, and we keep reading about, are drying, aquifers are under stress, glaciers are retreating, and the lack of reliable water contributes to agricultural abandonment, declining livelihoods, the rise of ghost villages. And so I'm going to look at issues around water and focus on that whole source sustainability issue. I'll start with where water is, what are the different approaches of managing water, and above all, I will focus on the importance of Himalayan forests to aquifers and water recharge. But I'll start with a slide. This is the kind of image we get in mind when we think of the Himalayas. The third pole, as it's known, it's the largest volume of snow outside of the polar regions, and this has led to a somewhat glacier-centric view of Himalayan hydrology, which I hope to challenge. But before I get into that, let's just talk very briefly about where the water is. As we're all aware, most of the water lies in saline water, in oceans, seas, bays. That's about 96.5% of the water. And if we let me try and put a pointer here. I don't seem to be able to get it. Okay, anyway. If we exclude the saline groundwater, it's about 97.5% of the water is saline. So we are left with just this 2.5% or so, which is fresh water. Much of it, about 70% of the fresh water, is sitting in ice and glaciers, about 30% is groundwater, and only 1% is actually surface fresh water. And even that includes a fair bit of permafrost, but it also includes all the rivers, the lakes, again, lakes being much bigger than rivers. And the actual amount of water that we find in rivers, streams, all of these things that we think is where the water is less than 0.5% of the total fresh water, or only 0.001% of the total water on the planet. But since in the Himalayas we are talking about the third pole, we should be in good shape, I would expect, or we would expect, given that 70% of the fresh water is as ice and glaciers. But if we, how do I move my slide? Okay. If we look at this next slide, you'll find that much of that ice and snow is sitting either in Antarctica, almost 90% of it, or in Greenland. We don't talk about the Arctic ice caps because that's saline water which freezes and unfreezes. But most of the fresh water in snow is sitting in these two poles, the Antarctic and Greenland. And all of the other snow and ice all across the planet on all the mountain systems is less than 1%. And the Hindu Kush Himalaya is only 0.02%. So it's not, even though it may be the third pole, it's not a very massive volume of ice when we look at it globally. So then we look at groundwater, the other big repository of water. And there again, if we look at the mountains, they are not comparable to the Indo-Gangetic plains. The thick alluvial aquifers, which per unit area would be storing a lot more than mountains, which were initially thought of as the sort of mounds of granite in which there was no water storage at all. But recent work, and again, coinciding with the kind of time that Himanshu's been working, but I'm talking about the sort of global research, has also been fairly extensive in the last 20 years, which shows that mountain aquifers store a lot more water than was otherwise being thought of. You have all of these geological structures from permeable and consolidated sediments, the talus slopes, the till deposits, where this water is stored. So let's take a quick look at, again, this snow and ice and its contribution across the Himalayan arc. Yes, in some areas it's fairly extensive. So if we look at the Western Himalaya, and these are the watersheds of rivers as they emerge from the Himalaya. So if we look at the West, the Indus as it emerges from the Himalaya is about 2/3 dependent on snowmelt. In the eastern side, the Sangpo is, or the Brahmaputra as we know it, the Yalung Sangpo, we call it the Brahmaputra when it enters India, is about 1/3 water. But while these watersheds are large, the quantum of water in those watersheds is relatively low. In Tibet, where a lot of these two watersheds I've referred to lie, the average annual rainfall is only about 30 centimeters. Whereas as we move down to the outer ranges of the Himalayas, the southern ends of the Himalayas, annual rainfall goes up to almost 10 times or 8 times as much. And if we look at those watersheds, which are predominantly the watersheds of the Ganga, the contribution of snow is relatively less, usually under 25% and often under 10%. So snow and ice is not as big a deal as has been made out to be traditionally in the literature. If we look at, this is a recent paper that just came out a week ago in the Proceedings of the National Academy of Science, and it talks about this unprecedented drying rates of the Ganga in the last 30 years, and which is exceeding the rates ever seen in the last more than millennia, in the last 1300 years or so. Now, again, they've talked a little bit about snow and ice, though, of course, the major reasons are diversion due to canals and irrigation and all of that. But what they've also said is that climate change doesn't account for this drying. It is either human factors such as these canals and other such things, or they talk about a little bit about snow, ice, all of that. But what I think has not been stressed on enough is the mountain aquifers. And that's the area I plan to focus on in my presentation. Now, when we look at the Himalayas again, the total quantum of rainfall is more than the global average. So there's no major shortage of water in that region. The issue is the periodicity of water. We are fortunate to be blessed with the monsoons, but that monsoon over a very short period of time dumps most of its water. So this is a climograph from Nainital, and as you can see, 80% of the water falls during those 4 monsoon months. And this is true for much of the Himalaya. If we move east into Cherrapunji, for example, in the East Khasi Hills, there too you see this phase of about 3 months where there is virtually no rainfall. And this is the issue. This is the issue with water across the Himalaya, that there is a prominent dry season when water is inadequate. And water being inadequate is not an option. We need water to survive. We need water for livelihoods. We need water for settlements, for any of this to function. And this strong variability of rainfall makes much of the lesser Himalayas, at least, a groundwater dependent ecosystem, where groundwater helps ensure the biological processes run, ecological processes run, and that's what ensures that human habitations work. A small spring will give you hundreds of thousands of times more water than any kind of tank storage that we would make. And here's a visual I like about the importance of springs. This is a picture I took in Ladakh a couple of years ago, and you have this vast desolate landscape, and in that this little ribbon of green, which is attesting to the fact that there's a little source there which is keeping that little pocket green. So now, what is the issue? Why are springs drying? Now, as Himanshu will tell you, that much of the mechanics of a spring is what lies below the spring, and there's not much we can do. It's the underlying geology which defines which are the permeable zones, which are the zones, which are the geological structures where water can accumulate. And where water can pass through so that it can emerge eventually as a spring. But while we can't change the structure of a spring, what we can change is how much water is recharged in that aquifer, which will determine how much water emerges from that spring. And that is dependent on a whole bunch of factors, in particular precipitation and the distribution of precipitation, and also how we use the land. So I sort of made this very simplistic conceptual diagram, just put things into 3 buckets: what changes, spring, discharge. And we'll spend fair bit of time now focusing on these 3, especially that last bucket. So one is climate change. Does climate change influence spring discharge? Well, in India, the noise is so much because of all of the other factors that we can't really be that sure. But the total quantum of rainfall, if we look at the Himalayas as a whole, is not changing. There are pockets where there is slight reduction, there are pockets where there is an increase, but there is no clear trend in total rainfall. What is changing, however, is the periodicity of the rainfall. And in some areas such as Poland, where there haven't been too many land use, land cover changes, there is data to indicate that the changing periodicity of rainfall, the more episodic rainfall that is occurring now, is leading to a reduction in springs. And there is some work, a good paper from a couple of years ago. This is a graph from the Himalayas. This looks at, we looked at the number of consecutive days. This work was done by S.P. Singh and others. They looked at the number of consecutive wet days and the number of consecutive dry days. And this is in the central Himalaya, and there's a clear trend. So in Uttarakhand, for example, we used to talk about the Sajjhara, 7 days of continuous rainfall. Those have become rare. And this graph shows that as well. As we move from the 1970s to the 2000s, the continuous number of wet days that occur in succession is clearly dropping. And even within this, there is a trend. So instead of rainfall, light rainfall occurring over several days at a time, it's now heavy rainfall occurring over a few hours. When heavy rainfall occurs, it just sort of slides down the mountain. It doesn't have the time to infiltrate. So this is a big reason when we talk about climate change. This is the major aspect of climate change that's making the difference. There are, of course, others, including increased evapotranspiration, etc., etc. Now, in geological changes, the Himalaya is an active geological structure. You have earthquakes, things change, springs change, some springs dry, some springs appear, but you'd expect more or less a sort of net zero there. What does make a difference is when humans start blasting, tunneling, boring through mountains, as this picture here shows, and that disrupts the sort of superficial or shallow subsurface watercourses which dominate Himalayan hydrology and will disrupt springs. But the biggest change is the land use change. And in the Himalayas, land use change is, study after study is indicating, is the major cause of spring decline. And when we look at land use change, the big thing is the reduction or change in forest cover. And that's what I'm going to talk about now for a fair part of the rest of this presentation. Now, this is a picture I took only a month ago. This was in Uttarakhand near Mukteshwar, and it had been raining continuously for about 4 hours. And I was passing areas of built-up areas where there were these streams of muddy water flowing. And then I passed near this forest watershed, and it's been raining here as well for 4 hours, and there is not a drop of water flowing out. And that kind of shows you a little bit as to what forests are able to do. I'm going to talk a little bit about the work that Bruinzeel has also done. He's asked me always to advertise this little book that we are coming out with in the next couple of months. It's on forests, but there's an extensive chapter by Bruinzeel on forest hydrology, and I think it's the best compilation of Himalayan hydrogeology that exists, and that's all his work. But I'll do a quick 101 primer on forests and forest hydrology. So what happens when it rains in a forest? Much of the water just falls through the trees, between the trees, which is called direct throughfall. There is also a fair bit of water that gets evaporated and transpired by the trees, and a fair bit of water that falls on the tree canopy and then is evaporated directly. That's called interception loss. And depending obviously on the quantum of rainfall, the amount of rainfall, the distribution of rainfall, that will vary, but 20 to 30% is just a sort of mean number. And then trees also transpire a lot of water. So a lot of the water that is in the subsurface layer is pulled out by the roots and transpired. So a lot of the water falling on this ground is lost. I think someone's drawing on the screen. That's not me, I don't think. So does that then mean forests are bad? Do forests result in more loss of water than gain? And that's something that we need to look at, and I'll try and explain over the next couple of minutes. Is there any way to get rid of these lines? I don't know how they've appeared. So here is a model that's more useful to us. When water falls and on the ground in a forest, a lot of it is soaked up by this leaf litter and duff, the spongy, semi-decomposed layer. The trees create lots of better roots, mycorrhizal connections, and that helps in the absorption of water. So what happens in a forest area is that the infiltration is fairly high, which goes as subsurface flows or as deep leakages into the aquifers. And what we call the infiltration excess overland flow, which is the water that is flowing out, the water that causes erosion, is much less and is very little often from good quality forests. Now, what happens when we remove the forest? The total quantum of water is going to increase significantly, and there's a lot more water that will reach the surface. But because there is no protective litter layer, because there is compact, less permeable soils, the infiltration will be less, the deep leakage will be less, and you will get that muddy water. So a lot of the water will flow straight down the mountain. It will cause erosion. It will cause that muddiness. And more importantly, because of the more episodic water and rainfall that we get, it's going to cause floods, disasters in the downstream areas. I know Ravi will want to talk about that, so I will leave it to him to talk more about. But this is the difference between a forest area, very low infiltration, overland excess flow, and a degraded area. So then this doesn't seem too good either. So what happens? Are forests good or bad? I haven't answered that question. And to answer that question, I'm going to go into the plains. Let's take a hypothetically completely flat ground. Now you might say that doesn't exist anyway, and that's true, but we'll use it for our modeling purposes here. And if we look at Delhi, I think the Yamuna is at about 200 meters above sea level, and it takes, about 2,100 kilometers before it empties through the Ganga into the Bay of Bengal. So we are talking about a gradient of 1 in 10,000. So it is pretty much flat, even at Delhi. Now let's compare forest and no forest here. When it rains in a forest, as I said, evapotranspiration losses are higher, interception losses are very high, but the water that falls in the ground will infiltrate well. You have good permeable soil, it'll get through, and there'll be deep leakages. In the flat area, well, in the mountains, that water would just flow downhill, but if it's a completely flat area, it has nowhere to flow. So it might take longer to infiltrate, but a lot of it will eventually infiltrate. So in the plains, the answers are not very clear. Not having forests does not necessarily reduce infiltration. In many cases, it might actually increase infiltration because the water has nowhere to flow and it's just going to stay there. But in mountain areas like these, forests have a big role to play. They hold that water. They keep that water from flowing downhill, and therefore they help infiltration. We'll get on to the concept of recharge zones and all, or maybe Himanshu will talk a little bit about it. But all things being equal, there is a lot more infiltration when you have forest areas. And this is a picture I took recently of an oak forest in Uttarakhand, and you can see what I'm talking about when I speak of thick leaf layers. Under this is the layer of semi-decomposed leaves, which takes years to decompose, and you have this thick, spongy kind of effect, which just holds and traps that water. And recent studies, for example, this one by Aman et al., show that this water can be held for several days or even weeks in this litter layer. So how much does litter impact forest hydrology, or how much does it impact infiltration? The answer is we don't know, because there just aren't very many good studies that look into this at all. So what I've put up here is some studies to show what happens with leaf litter when there is a disturbance in the forest. And these are two independent studies, both of which I was involved in, and there aren't too many studies on this, unfortunately, as well, in the Himalayas at least, which show what happens when a forest gets degraded. The total quantum of litter decreases, which is obvious. If the forest is getting degraded, there's lots of lopping happening, trees are being lost, the amount of litter is going to decrease significantly. But also the amount of litter removal increases. So from between 9 and 20% in these two forests. So even in and this is interesting, even in an undisturbed forest, there is a fair amount of litter removal happening. So we are saying this is the protected, and these were forests under high levels of protection, but litter removal still happens. And the difference between a true undisturbed forest and a degraded forest, as you can see from both these graphs, is about sixfold. And these are all forests. We are not even talking about deforested areas here, which would have, as you would expect, no litter. So what does this do? We don't know the full implications of that. What happens to the mycorrhizae? Mycorrhizae are the fungus that really help a lot of our trees draw nutrients and water. What happens to the mycorrhizae? And this graph is very interesting because if we look at these two lines indicated by these arrows, these are both intact canopies. These are both what we would call undisturbed forests. But one has litter removal, one has very little or no litter removal. I mean, we thought there was no litter removal, maybe there was a bit, but there's a five-fold difference in the mycorrhizae in these two forests, both of which have good canopy. So this is an area which requires a lot more research, understanding to really see what forests do. Here's a degraded area that used to be a forest, and I know it used to be a forest because of the evidence we found of past forests there. But as you would expect here, all the water is just going to flow down. This is a hard, impermeable surface, very little mycorrhizae, very little of anything. The water just flows down, causing erosion, causing those sort of flood surges which cause disasters. Now, a little bit on managing forests as I get to the last sort of sections of my presentation. The old approach was the watershed approach. This was popularized in the 1990s. I still have a lot of faith in it. It followed a sort of ridge to valley approach. And the idea was to reduce erosion, increase, and thereby hold the water a bit longer, and that would increase recharge. It focused on managing surface waters and on enhancing soil moisture. And you build structures such as gabions and check dams and just contour trenches and just prevented the flow of water in general without worrying about the subsurface geology. Himanshu and Aquadam introduced the concept of springs and recharge zones, I mean the recharge zones of springs about 20 years ago. And they suggested that it would be much more useful to understand the subsurface geology, to understand where these recharge zones of springs are. And if we could then treat those recharge zones preferentially, we could treat a much smaller amount of area and achieve the same results. So this is a sort of simplistic diagram of the kind Himanshu would probably show. It also is conceptually important here because they advocated also a valley-to-valley approach. As you can see with this spring here, the water actually comes in one side of the watershed and ends up in another watershed. So instead of a ridge-to-valley approach, a valley-to-valley approach. Currently, and Himanshu does talk about this as well a fair bit, and this Tambe paper is also one Himanshu was involved in, the landscape approach has become much more prevalent. So recent studies indicate that Himalayan springs are connected and share aquifers. These are interconnected by fractures and other things, and the water, it's all one giant landscape with interconnected aquifers. And some recent work in China and Tibet by Fan et al. Have shown that that over 30% of the water of the Yarling Tsangpo, the Brahmaputra, when it's in Tibet and China, seems to disappear. And they speculate that this is deep inflows which might emerge 1,000 miles downstream in the Indo-Gangetic plain. So this is the sort of model that we should be looking at now, which again shows everything is connected. And given all of these fractures and all, maybe the recharge zone is a little less discrete than we initially thought. And hence, again, the low-cost way of dealing with this, of increasing recharge, is forests. Do these approaches work? Yes, they do. And every organization in this consortium probably has graphs like this. Chirag has done some excellent work. PSI has done fantastic work. This is a graph from Himmothan. And all that these show is that when you treat these watersheds, the peak discharges decrease and the base flows increase, which is exactly what you want. Less flooding, more soil moisture, less forest fires as a result of more soil moisture, and better vegetation growth, better agricultural productivity. This is using remote sensing, using NDVI, which is basically a ratio of red to far red, near infrared. And what it tells you is about the vegetation health. These are treated, the areas around treated springs, some work that was commissioned by Himalayan, and you can see the NDVI increasing. So this is another way to show that the spring recharge has become more uniform, is occurring across more of the year, which is providing those trees with better moisture. So Himalayan had also done this very interesting survey of some 10,000 springs. So each of these dots, this number represents the number of springs. So this is 17 springs that is covered by this one dot, and this dot is 2 springs, and this is 6 springs. And so when I talked to the people who had done the survey, they said, yeah, we've surveyed all the major springs, everything's done. But when we mapped it out, we found these big patches where there were no springs. And these coincidentally were largely forest areas. Now, this to me, and I wanted to spend a few seconds here to say that these to me are actually the important springs which are being labeled as the unimportant springs. These are springs we know almost nothing about. Almost no survey will have them, because when you ask people about them, they'll talk about the springs they use. They don't talk about these springs which they don't use. But these are the springs that empty into streams and rivers. These are the springs that when we want to lift water for urban settlements, these are the springs that will matter. Or when we worry about Namami Gange or the base flows of rivers in rivers such as the Ganga, these are the springs that are really contributing the most and really need a lot more attention. So that gets me into the last bit about the Himalayan Water Partnership. This is a group of organizations that have sort of come together, agreed to work together. It's still very much an evolving a consortium, but we work across the Himalayan arc. You have experts who've worked in the region for over 20 years in water supply, PSI, Chirag, Himalayan, but NEDA, CML, CEDA has done some excellent work in urban water supply, and they all come together with the idea of being able to influence better water management across the Himalayan arc. So what I've talked about today more is source sustainability. And that to me is critical because it is what doesn't get enough attention. But when we look at the consortium as a whole, it looks much beyond. So water supply is essential. Fine, we have the sources, but we don't want these people, women in particular, lifting water, taking it far away. So you need to talk about the water supply issue, equity, governance, livelihoods. I mean, this water is essential to maintain, from a Himalayan perspective, to maintain those settlements there and to ensure that livelihoods can continue unaffected. And the consortium really is trying to look at all of these things. I haven't talked about rural water supply, but when one talks about Himalayan water, the larger government schemes, they tend to focus on the supply side issue. But as we've often said, that unless the source sustainability is there, focusing on supply side issues is going to be less relevant. But organizations such as Chirag and PSI, I think, have now a quarter of a century of experience in this. So if you look at Himalayan and NEDA as well, between all of these organizations, I think they've built well over 1,000 water supply schemes for different settlements. So there's a lot of experience in this. One thing I haven't talked about, and which is important and which tends to be ignored by government schemes, is understanding tradition, culture, customary practice, and most importantly, governance. This is critical if you are looking at water supply. There's been great work done in the past. The survival lessons, this was a fantastic publication brought out by PSI, and Ravi Chopra, who's one of the discussants, is the author of it. We've talked, there's been a lot of talk about the Nolas and Dharas of Kumaon. In the Northeast, you have all these fantastic, traditional structures, bamboo pipelines, conservation structures in Leh, Zings and others. And these tend to be neglected when you look at these large centralized projects. But they're critical if we want to look at sustainability. Urban water supply is another area which tends to be neglected especially by the development sector. It tends to be very engineering heavy. It doesn't look at nature-based solutions. And this to me is a big problem because sure, we can't depend on local springs any longer to supply towns. I mean, Almora used to be supplied maybe 150 years ago entirely by springs. Today, that's not possible. But if we could conserve springs, if we could increase this connect with springs, the resilience of these towns would go up considerably. You have a disruption of water supply, that one pipeline that is lifting water from the Kosi or whichever river, and the whole town is going to go dry. But if you also have a codependence on springs, it would allow for a certain amount of resilience to come into these systems. Urban water supply is a very difficult area to deal with. There is a complexity. There's a myriad of agencies that deal with, some that deal with maintaining the pipeline, some with building the pipelines, others with tariff and all of that. So these are difficult areas, but we cannot ignore the growing urbanization that's happening across Uttarakhand. And these are some of the sort of factors that worsen the Himalayan water crisis. I've already alluded to them. A move to, but again, these are economically justified and important. We can't say these should not happen. Yes, there is a move from food-centered subsistence farming to a market-driven, resource-intensive cash crops, horticulture, apples, and other such things, vegetable growing. But this is important economically. Tourism is important economically. We're not saying stop these things, but what we're saying is find ways to make them more sustainable, find ways to reduce the impact of these, not just on water, but on other aspects of the natural environment as well. The government construction tends to be pipeline-based. It leads to a loss of connect that local people have with their local springs and water sources. This, I think, is a big issue that needs to be looked at when the government is also planning how to keep that connect alive, because that is very important. Lastly, a couple of slides on what the consortium is dealing with. These are some of the areas that, the thematic areas that we hope to deal with. These are some of the operational strategies that we look at. It's all evolving as the organizations come together and discuss more. These are all going to change, so I'm just keeping it at a minimum. So I think I'm within my time frame, fortunately. Thank you very much. And I think this leaves us with adequate time, both for the discussants and some question and answers. Thank you.
Thank you, sir. That was such an engaging presentation. It highlighted the limited share of fresh water within global water resources, and it also underscored the undeniability of drying of springs. So, yeah, so this discussion also emphasized how forests directly influence the infiltrability of land, so which plays a central role in groundwater recharge and the revival of springs. So, yeah, that was just a summary of what I could do, and it was such an engaging presentation. I thank you again, Rajesh sir. I would we are fortunate now to have today with us two leading practitioners, Dr. Himanshu Kulkarni from Aqua Dam and Dr. Ravi Chopra from PSI. So we'd now like them to respond to this presentation and would request them to reflect specifically on the water livelihood linkages in this region. So yeah, over to them. And just a small note, we would invite any questions in the chat. If anybody has any questions, please put them in the chat and we would look at them after the discussion. Yeah, thank you. Yeah, over to you, Subs.
Ravi, would you like to go first, please?
No, Himanshu, you can go first.
Okay, Ravi.
You are my guru in this field.
Come on. Okay, so here goes. I think what I'll do is, while Rajesh gave his excellent presentation, I was taking notes and I thought I'll put up a few slides quickly. So let me do that. Yes, Priyanka, is my screen visible?
Yes, sir. Yeah.
It is.
Yes. So I'll take a minute each on each slide. And let me just get this out of the way. Maybe put this here. So yeah, the first thought I had was, yes, springs, and because I think the question of livelihoods came up, spring water actually supports a variety of uses. And it does so across a wide-ranging typology. And I'll tell you why I've used the word typology here. So yes, we know that drinking water, domestic water usage, religious purposes, cultural uses, agriculture increasingly so, ecosystem services, rivers, from which there are many other uses, and of course, forests and that connection that Rajesh talked about. But I think springs increasingly has, if you look at the Himalayan regions, the distribution of springs actually happens across, there's a latitudinal zonation as you go from the south to the north, which is essentially driven by the geological transitions in the Himalayas. Then there are longitudinal zones from the west to the east. So the drier western regions to the eastern wetter ones. There are, interspread with these is the question of elevations. And you have to also understand that altitudinal zones defining different climate and different ecosystems also play a role on how spring water is defined and how it behaves. Now, I think what we are bringing to the table as a group over the last 10, 15 years, purely through an experiential journey. I mean, this is completely aloof of what research has been telling us. And I find that, I'm going to say this a little ambitiously, maybe go overboard, that I think till about 10, 15 years ago, there was hardly any recognition to aquifers in the mountains. Because, different organizations were telling us that, you look at slopes of more than 20 degrees, and you wouldn't find groundwater in slopes or, in gradients which show 20 degrees or more. And therefore, what actually one is talking about is there's a fourth dimension to this variability, which is the subterranean dimension. Variations that are defined by the complex geology and its interplay with the water, its interplay with the ecosystems. And I think this is extremely important in understanding groundwater, whether it's in the mountains or in the plains. And I think this was a big game changer. I'll quickly run through this very old graphic of what spring sheds mean. So you have two springs in a landscape which is defined by about 6 micro watersheds. And if you actually bring this subterranean dimension with fracture systems, with the dips of rocks in the Himalayas, with the folds, with the faults, you can actually begin to define aquifers. So you actually have 2 or 3 aquifer systems here. And if you look at my arrow, there's one here, and there's one here. And depending on this, you then come up with which springs are getting recharged from which areas. So, for example, this spring will draw water from rainfall or infiltration that goes in this zone, which is part of watershed 4, part of watershed 5, and maybe a little bit part of watershed 6, and so on. So, you have something called spring sheds, spring shed 1 and spring shed 2, which is an integrated combination of the watersheds and the underlying aquifer system, which together contribute to the feeding of the spring. Now, this happens over a large area, so therefore, it's become more and more important now. Sorry for the disturbance, something outside. It's become more and more important to look at landscapes which have many, many spring sheds, and then work at that scale if you really want to make a difference. Now, quickly going forward, not all springs are defined by a valley-to-valley system. We have come up with a typology of 7 or 8 situations, which actually bring in this combination depending on what, and there could be more, depending on the various permutations and combinations that we have come across in the work that we have all done together. And I think a ridge, watersheds, underlying geology. So there are several combinations. And I think that's also the reason why one has to work at the local scale to really come up with the proper approach, with the proper systematics of going forward in implementing, first of all, designing, planning, and then implementing springshed management programs. Also, this plays a great role in impact assessment. Because if you're going in for advanced techniques like isotopes, both for planning and impact, then it's important to do fundamental geology and hydrogeology to define how your isotope sampling is going to happen. So for instance, if you look at a system, a complicated system like this, and if your sampling is restricted only to this slope where you get the springs, then you actually have an incomplete sampling without, I mean, despite the fact that you are one of the most developed technologies of understanding surface and subsurface water in the world. So what's the point of bringing in a technology if you're underprepared? And I think this is one more reason why I showed you the slide, that there are very various situations. And together, as a consequence of all this work, along with ICMOD some years back, we developed a step-by-step protocol on understanding, designing, planning, implementing, and measuring impact of springshed management. And like Rajesh said, this is actually a work in progress. And this can be further improved. So to end, I'll actually use a few photographs. So, like Rajesh said, today's focus on springs is the immediacy of how spring water is affecting the lives and livelihoods of human beings. But we know that a lot of the wetlands, a lot of the small seeps, bogs, wetlands, or even large meadows and grasslands that sit on very large spring systems, such as the ones that you get in Ladakh or Spiti Valley, are a consequence of this entire system of aquifers and land and land use. I mean, one of the things you have to also understand that you also get springs in high altitude regions where there's very little vegetation. And you get springs in regions which have very dense forests and grasslands. So you have to also understand that the typology of springs is complicated, both in terms of existing land use, land cover, and how it changes, and also in terms of the underlying geology. One example I can give you is in a terrain like this, and this was work that we did in this around the town of Leh many years ago. And the whole understanding of glacial processes, and especially how the moraine geomorphology or the glacial geomorphology develops and how it contributes to springs. So we found that a lot of the springs in the high altitude regions, especially in the glacial regions, are around moraine deposits, especially the lateral moraines. And I think these are then, in many ways, these moraines actually become aquifers. And you have to really understand these moraines. You have to also think about what infrastructure development is doing to these moraines, because moraines in infrastructure language today is really about wasted earth, and they can actually be used in construction. But when we actually remove a moraine, it means you might be removing a potential aquifer that feeds springs. And these happen to be at large scales. So this is just one example on how we need to conceptualize our own mindset to understand springs and spring sheds in different contexts. So I'll just conclude by saying that the concept of spring sheds is really about understanding the congruence of aquifers, watersheds, landscapes, and societies. And in order to really solve the problem of a drying spring in village number 1, it's important to bring all these disciplines together, because unless you do that, you won't be able to identify the recharge area because of the integration between watersheds and aquifers. And second, more important, the recharge area for the spring in village number 1 lies in land owned by village number 2. So unless you are able to bring these two communities together to cooperate in some manner or the other, it becomes a problem that you will only partially solve. And therefore, multidisciplinary approaches to spring shed management is the only way of solving a problem that is multidimensional, even as small as it may seem visibly or physically, that, oh, it's just a little idly-widdly spring in this village. So what's so great about it? Let's go and work in that village and solve the problem. It's only a partial solution to the problem. And therefore, I'll actually leave you with maybe a 30-second video of what I spoke about in a kind of a visual form. So kindly bear with me, and then I will, of course, stop sharing.
If you look at the spring source, the point of emergence, the aquifer which we talk about, which feeds that particular spring, may be spread across, one hill or maybe spread across multiple hills. You have to consider how the aquifer extent is present that is feeding the spring, and on the basis of that, you'll have to, design your intervention plan. And that is where in a spring shed, you actually integrate your surface, you integrate your watersheds, and you integrate your subsurface geology. Spring shed is basically integration of all these 3-4 components.
Over to you, Priyanka.
Yes, sir. Yes, that was such an engaging presentation again. So yeah, I think I would give it over to Ravi Chopra, sir, and then we can go on towards the discussion.
Okay. I'm going to basically talk about disasters, urban springs, a little bit about landslides, livelihoods. The glaciers are important because until now they have been able to provide us with perennial flows, but they are melting, and even before they disappear, they are fragmenting and forming glacial lakes. The number of glacial lakes is increasing, and therefore the threat of glacial lake outburst floods is also increasing. Now, my own guess is that even though we may be able to save lives, saving livelihoods will be more difficult in the event of a GLOF. A GLOF will affect the valley downstream, and much of the good agricultural land is right next to the river or the stream, and therefore that land is likely to disappear in the event of glacial flood. We can always encourage communities not to build their houses right by the riverside. They can move their houses up the slope. Similarly, there is an increasing tendency to build roads, highways along the rivers. This is a bad idea. It was never practiced by the British, and it's time that we moved upslope with our roads, because commerce follows roads and highways. And therefore, if we shift the roads and highways, then the commercial livelihood will also be safer. Okay. The second point that I want to make is that landslides are being caused both by climate change as well as by the rapid intrusion of development, so-called developmental activity into the Himalayas. As far as natural reasons are concerned, Rajesh has explained that we are witnessing much more intense, short periods of intense rainfall in the Himalayas, as well as cloudbursts. Now, this is leading to a lot of landslides, but on top of that comes the cutting of slopes to widen roads or to build roads. And slopes are being cut in areas where they should not be cut. Typically, the engineers have always recommended not to cut slopes above 30 degrees. But nowadays, we are cutting slopes of 60 or 70 degrees also. So, just to give you one number, between Rishikesh and Badrinath, the a study that was done by an international team indicated that there were more than one vulnerable landslide zone per kilometer of that highway. Okay, and many of them have now become chronically unstable. Okay, so that's one aspect of the landslide. The other aspect has to do with the Himalayan, the way the earth, the geology of the earth exists in the Himalayan region. We have these three major ranges. The Shivaliks are the southernmost, then come the lesser Himalayas, which is like Mussoorie or Nainital, and after the main central thrust are the high Himalayas. So Joshimath is standing at the edge of the main central thrust. In these areas, we get very focused rainfall. The low-lying clouds strike the Shivaliks, dump some rain over there. Slightly higher rain-bearing clouds strike the lesser Himalayas, and they dump more rain over there. And finally, the high-flying clouds go and strike the higher Himalayas, and areas like Joshimath get a ton of rainfall. Now, why am I saying, why am I bringing the issue of landslides into this? Because it leads to loss of springs. Just to give you some recent example, in Tharali, you may have heard that after the big avalanche in Tharali, a couple of weeks later, there was a major landslide in the Pindar Valley, and that leads to loss of springs on which people are currently dependent for their water supply. We have also seen that about half a dozen springs were lost between Rudraprayag and Agasthamuni, probably a distance of about 20 odd kilometers, when the road was being widened a few years ago. So that's the problem with these disasters. But another aspect is that of the changing weather pattern. We have seen in the last several years that the precipitation in winter is decreasing. This is primarily because the western disturbances that bring rain from the Mediterranean and the Caspian seas, the western disturbances are less likely to occur in winter and more likely to occur later in the year. So the dry period is getting extended. The winter rains would give us some recharge for our groundwater supplies in the Himalayas, but because of the shifting of the precipitation pattern, the dry period is increasing. Now, if you combine this with the deforestation that is taking place and the loss of infiltration, then the effect can be devastating. Let me try and show you a couple of slides. In this hydrograph, at the bottom of the screen on the right-hand side, you can see that back in 1994, this is the Kosi Valley in Almora. Back in 1994, we had a flow of 995 liters per second, approximately 1,000 liters per second at a particular location. There's a bridge on the river, and this was being measured in the center of the river. Now, just about 10 years later, in 2004, the flow has declined to about 100 liters per second. And this, you can see there's a steady decrease in the graph. Okay, so Kosi River is now being used to supply water to Almora. Almora was a city that was traditionally dependent on its springs, but we'll come to the problem of urban springs in a moment. The Let me go to the next slide if I can screen it. Yeah. I have to go back. Okay. This is one of the small watersheds, the Kolgad watershed, which feeds into the Kosi. And you can see that there are about a dozen small streams which feed into one large stream, the Kolgad, and the Kolgad ends in the Kosi River. 1991, a dozen small streams plus the main stream feeding the Kosi. And in 2004, almost all the small streams have disappeared, and there's just a tiny portion of the Kolgad left. So this is the kind of problem that we are facing in these. Now, how do I get, stop share? Okay. Let me come to the issue of urban springs. Urban springs are facing a number of problems, particularly in the rain shadow areas, and Joshimath and Almora happens to be in a rain shadow area. As explained just now, deforestation and climate change are drying up the springs, but this is compounded by the rural-urban migration that is taking place in most of our Himalayan districts. The arrival of fresh population means that not only is the population density going to increase, but the density of built structures is going to increase, and therefore the space available for recharging decreases. So that leads to drying up of many of the springs. In fact, some of the beautiful traditional water harvesting structures that we documented many years ago are now dry. But another problem is that there is very little thought given to sewage disposal. Very often we found in Almora that the sewage was just being uh, led into a natural drain, and once it goes into the natural drain, it tends to pollute the springs that are still active. Most of the springs in we found fecal contamination in most of the springs in Almora. Now, let's come to the issue of livelihoods. As you probably know, there is one major activity in the dry western Himalayas, which is the Ladakh, Lahaul, and Spiti districts. In these districts, until recently, until tourism began to take over, agriculture was a mainstay for the population. But that was dependent on glacier water, glacial melt. Their glaciers were small, and because they are small, they are also disappearing a lot faster. And therefore, their agricultural activity is now threatened in these areas. There are people like Sonam Wangchuk who've tried to create artificial glaciers. There are people like Thupsen Chuang who has many years ago demonstrated how to harvest the glacial melt and save that water supply. But I think the way out for them is going to be rooftop rainwater harvesting. And Himanshu could have added a lot more about the groundwater problems of towns like Leh. I'm not familiar with those. The final comment that I have to make is that when it comes to livelihoods, our experience at People Science Institute has shown that a landscape approach is quite useful. Uh, if you combine the watershed approach with its focus on spring sheds within the watershed, then you are able to take care of not only the water supply required for domestic purposes, but also for agriculture. And I don't have time to go into the story of Thana Kashoga area in Himachal, where PSI did its initial work with the help of Aquadam. But one of the amazing things was that once you have people's involvement in managing their springs, you can actually reduce the water demand in the area. Thank you.
Thank you so much, sir. That was also very nice and interesting. So I was wondering if we have time for a few questions.
So, Priyanka, there seem to be several questions in the
Yeah.
chat box.
Yeah.
Should we start
Mhm.
responding to some of them, or what would you like?
I guess that would work. I could read out the questions to you.
No, I mean,
That-
we can
Yeah.
maybe just also, to save time,
Yeah.
so should we just
Yeah,
take
that
on
works.
one or two each and then, I mean,
Yeah. Yeah, we can do that. Yeah. That would work.
okay, I'm seeing one by Puran Bartwalji about area under pine. What is the role of abundant pine needles as litter on reducing erosion and infiltration? So pine needles are pretty good. I mean, they also will break the flow of large droplets of water before it disturbs the soil and creates erosion. They will also hold water. The thing with pine needles is they rot a little less slowly, so they don't create as nice a duff and litter layer as oak forest. The biggest issue, however, with pine, which negates everything about pine, is the fact that it is very prone to fire. And people light fires there to improve the grazing areas for their cattle, to prevent slipping on those areas, both for themselves and their cattle. So most pine forests tend to be fired often once or twice a year or once in 2 years or thereabouts. Now that means that there is no leaf litter layer left and you have bare ground. So all of the impact of pine needles goes away just because we burn those frequently. If it was an undisturbed pine forest, it would be relatively effective. But the way 90% of the pine forests in Uttarakhand and the central Himalaya are, they tend to be, or the Western Himalaya, they tend to be not so effective as litter layers. If you go deeper into the monsoon shadow forest, where other species of pine, the blue pine, for example, Pinus wallaceiana, thrive, there the litter layer is much more effective because there the prevalence of fire is much less. There's a question, I'll just answer one or two randomly that I'm seeing on nature-based solutions for Jal Jeevan. I don't know that, maybe others can respond. I will say that there was a great study done. Vishal, I saw his name somewhere here, but Dr. Vishal Singh of Cedar led that study, which was done on Lake Nainital. And Himanshu and others also commented on it and were involved in it. What we found was that Lake Sukhatal, which is a valley fill lake perched above Nainital, is responsible for a lot of the subsurface flows into Nainital. And if Sukhatal is protected and water is allowed to collect there in the monsoons as it always did, and allowed to infiltrate through this valley fill and collect in the valley fill, and then the valley fill. So it goes into a practical demonstration of what Himanshu talked about. The typologies of springs is what he talked about, but here it's a valley fill where the water collects, and then through the main boundary thrust, the water permeates down into Lake Nainital. And there was some evidence gathered to show, and there were studies done by the National Institute of Hydrology and others to show the importance of that lake. And I think Vishal and others in Cedar started a movement which was taken up by the citizens of Nainital, which helped bring protection to Sukhatal, and that has significantly helped in the recharge of Nainital Lake. I'll leave it to Ravi and Himanshu to maybe respond to a couple of questions, or should I just go on? Would you guys like to do one or two before I?
Yeah, I can quickly do one. Actually, I've tried to answer Shipra's question in the chat on the policy thing. So let me also go back to this. I think Preeti had asked this question on cropping pattern changes. And I think since Ravi prompted me to talk a little bit about Thana Kasoga, I'll do that. So Preeti, to your question, management has many dimensions. So if you actually work at the scale of a large watershed and then bring in the concept of spring shed, there are two areas in which you can make an impact. You can augment the aquifer recharge through systematic recharge of spring water, or through systematic recharge of aquifers, through a fairly internationally acknowledged and customized system of managed aquifer recharge. And of course, there are questions on whether this will lead to landslides and all, but that's exactly the caution that you need to exercise. And second, on the demand side, especially if spring water is being used for intensive agriculture, growing a certain crop, then there's a demand side intervention that you can make, because eventually both these lead to the drop in the water security for domestic water. So to cut a long story short, what PSI did is there are three levels of impact. With this work, they were able to increase or augment recharge to the tune of almost 20,000 cubic meters per year. That's the augmentation. So the recharge increased by 20,000 cubic meters per year. But through their intervention on systematic cropping practices, they were able to bring down the demand by another 10 to 12,000. So effectively, the net gain from this whole exercise was about 30,000 to 35,000 cubic meters per year. That's the net gain. So that's the kind of impact you create. But in addition to that, there are other measures that they took, and that's the third dimension, and I'll stop, which is about the water quality in the spring. And therefore, you have to be very, very careful in, for example, designing waste disposal, sanitation practices. So you might go from open access to closed sanitation, public sanitation. And if your public toilets are built on recharge areas with poorly designed soak pits, then you might actually go around and disturb the whole spring system. So I'm saying that even designing sanitation also requires an input. And I think with this input, they were able to also bring down the fecal contamination by a significant number. I don't have those graphs readily with me, but I can share them as a part of, add them to the presentation PDF that I will share with the organizers to be shared with you all. I think I'll stop at that and hand it over to Ravi.
Thanks, Himanshu. I can see basically one question that's left for me, and I'm quite happy to respond to it. That's by Manoj Kumar. Any impact of Western disturbance on Himalayan ecosystem? I do not recall any major study of this sort. It's a relatively more recent change, but one physical problem has arisen, which is the increase in the number an area covered by forest fires. Forest fires are now starting a lot earlier. We are seeing certain indications of the shift in the Western disturbance period, uh, the emergence of certain vegetation much earlier in the season. For example, rhododendron is often cited that it used to appear towards the end of March or April, and now you are seeing rhododendron flowering take place as early as the end of January. Second question you raised was, why can't government do developmental activities little differently in these fragile ecosystems? Uh, the government seems to be in a headlong push for rapid economic growth in this area. As a result, not enough time is allotted for doing prior geological investigations. So the geological investigation work is extremely poor. And you may have seen in the newspapers recently the Minister for Roads and Highways saying that actually the detailed project reports are not made on the basis of site visits. They are made sitting in Delhi and going over Google Maps. And that's the kind of laparwahi, as I call it, that is being done. Uh, the laws, the environmental safety laws like EIA, social impact assessment, the how much degree slope should not be cut, all these are totally ignored in this headlong push to complete a project. So that, to my mind, and of course, people are just not involved in this. People's complaints, people's suggestions, people's recommendations, they are just not considered in all this planning. Thank you.
Can I just briefly respond to a couple of questions that I just saw coming in? So I see we're running out
Yes,
of time. So I'll just do a very brief. One is an interesting question about springside management causing landslides, and I think that really is a fear, because if slopes are steeper than I think 45 degrees or so, and they get saturated, there is always a chance of a landslide. So where you site your contour trenching, if that's what you're doing, is a concern, and you don't want to hold water on very steep slopes also. So I think that is a genuine concern. Forests tend to negate that to some extent, because trees tend to have deeper roots, which at least shallow landslides they can prevent. The deeper landslides, forests do not help prevent at all. There's a question about groundwater recharge and abandoned agriculture. And there is some data to show that as agriculture is abandoned, the ground actually gets harder and groundwater recharge decreases. But this is likely to be temporary. As forests grow on those lands, the soil structure will again improve, and the groundwater recharge will improve considerably. So it's a sort of a temporary phase where the recharge falls down. The other thing which is related to some of the questions and some of the things that were said, especially this pine and all of that, we have, at least in the central Himalaya, vilified pine and had this thing that pine is invading onto oak areas. One is that it invades onto oak areas because we help it invade onto oak areas, and I can talk for hours at length on that. But pine is the expansion of pine is solely because of human interventions. B, I think in the central Himalaya, in Uttarakhand, Himachal, Western Nepal, we are now reaching what is known as a forest transition, where the decline in forest cover is slowing down, has stopped, and is now increase in forest cover is likely to happen. It's a result of several things, including growing affluence, including the fact that the government has been very effective in LPG penetration into these areas, including the fact that surplus cattle are not being kept, and AI and others have come in, and the number of cattle have fallen dramatically. Agricultural abandonment. There's a whole host of reasons, but this is also going to this is also needs to be factored in when we are talking about groundwater recharge. Lastly, there's been several references to Western disturbances, and a question is well. One is, of course, that Western disturbances seem to have become a little. So It's the westerlies that come in for a fair part of the year, and the western disturbances are, and it was described somewhere as the westerlies are a highway and the western disturbances are sort of trucks coming on that highway. They are coming a little later, as Ravi Saab well pointed out, so that seasonality has shifted a bit. The interaction with the monsoons has now started a little bit more than I think it was. But the western disturbances are again geographically limited to one part of the Himalaya. They tend to be much more strong in the northern and western parts of the Himalaya, and as you come south into the Himalaya and move east, they tend to become much weaker. One point when we talked about glacial melts, which is interesting, is that because of these western disturbances, which have in some ways become stronger, the Karakoram area actually showed no glacial melt for about 20 to 30 years, something that was known as the Karakoram anomaly. So while the Gangetic glaciers were melting pretty rapidly, the glaciers in the Karakoram region were not melting at all, and in fact, in some cases were becoming a little larger, so they were not losing mass. That seems to have reversed in the last 5-7 years, and it's thought that maybe this Karakoram anomaly is over, and now even the glaciers there are melting. So the western disturbances are really interesting. We talk only about the monsoon because that's what gets most of the rain, but there's a lot that can be said about the western disturbances. Thanks. I think we're getting over time, so I'll stop.
So Rajesh, Priyanka, if I may just indulge that one question
Yes.
for a minute, because it's coming time and again, which is on the
Yeah.
landslides part. And I've tried to answer that in the chat box. But let me add a few things. See, I think there are two aspects. So a random implementation of soil and slope treatment without understanding where the recharge area lies. So if you put your interventions very close to the spring, and which is a discharge area, which is as it is fairly saturated with shallow water levels or shallow water with a shallow water table, then come a storm, a cloud burst, you will have failure in that slope because your saturation excess actually becomes more than your infiltration excess. And you already have an infiltration excess, but you have a saturation excess. And this is something we have actually explained as a part of a landslide study that we did in the Western Ghats. And we can actually share that through, with UNICEF's partnership and with Government of Maharashtra's partnership, we've actually done this study, which actually brings me to my second point, which is, I think more information, more systematic work on springs will also help us understand landslides better. So using springs related information might actually be a good way of, or might actually add another dimension to early warning systems. Okay. Third, I think a lot of this blame game that is happening right now is, okay, you have created a whole bunch of structures which are really very, very small structures up in the slopes up there. But you have to also remember that when slope failure occurs, there are other factors which might have contributed to that. So you have spring shed management there, but you also had tunneling work with the headrace tunnels going through the aquifer. You had cutting for large roads downslope, and then slope failure occurs. Now you actually have three reasons, but where do you put the blame? Fairly and squarely, because that's what everyone is talking about. You put it on the recharge interventions for spring shed management. So we have to be very, very careful in our analysis of this correlation between spring shed work. Yes, we have to be cautious about it, but sometimes the blame goes overboard without looking at other factors that cause the failure. So I'll stop at that. I won't speak anymore.
I have one comment on that too, which is that you can introduce a relatively simple engineering measure to reduce the probability of a landslide. Most of our trenches are staggered contour trenches. So if the trenched area is not too big, at the end of the last contour staggered trench, you make a contour trench which is continuous, and it goes from one end, on either end of it is a natural drain. So the water gets removed into natural drains rather than leave it on the slope. That's it. It's all yours.
Right. I think at this point we will conclude our discussion. There's several questions that we haven't been able to answer, but they're all very brilliant, and I hope we're able to touch upon some of these things in our future sessions. But I just wanted to thank the speakers and the speaker and discussants. Thank you for Rajesh sir for your really good presentation on springs, forests, mountain aquifers, and you really set the stage for the discussion on both science and practice to follow. Yeah.
Urna, I'd just like to comment on these last couple of questions, one from Yusuf and one from Puran.
Sure.
You know, you guys are the ones who are interacting directly with various government programs. Take the messages to them.
With that very pertinent and okay, I think Yusuf sir, do you want to
Yeah, it is always pleasure to hear Raviji and Dr. Himanshu. So yes, I totally agree. Now the National Adaptation Plan is being drafted, and unfortunately, it is not focusing on different agroclimatic zones. So whatever we are discussing about the Himalayas and the glaciers, the entire issues. So how do you integrate all this body of evidence and knowledge? Can we show that because of this kind of intervention, whether it's a nature-based solution linked to the technology, we could able to kind of strengthen certain flagship programs like Atal Bhujal Yojana, Jal Jeevan Mission, Amrut Sarovar, or the recently introduced National Water Security Program, and of course the entire issue of the soil entire issue of the soil conservation. So of course, as you said that these days policy making is very complex, and of course we are here to bring to the policymakers. But if we can link with the flagships, central flagships, and the SDGs, I think this will bring a larger evidence, and it will be much more convincing for the policymakers, because India is updating the NDC, and in the NDC, I was searching the word Himalaya, glacier, everything. I could hardly find those few words. And National Adaptation Plan also, they are speaking about water security, but as a general subject, India has more than 20 agroclimatic zones. So you cannot have a one size fits all. So that's why I raised that questions. Thank you, Raviji. Thank you, Dr. Himanshu, and thank you, everyone. Okay.
all right, if there aren't any other comments to be made, I think I will conclude this session as of now, because we don't want to be taking up more of people's time. But yeah, just to like finish off, thank you everybody for your firstly for the speaker and discussants for your really interesting and important contributions on mountain aquifers, springs, spring shed revival, as well as disasters and climate change. And yeah, I think we've really been able to touch upon some of the broad issues, the evolving problems, as well as the tensions and the debates on how best to go forward. And sorry about that. My bad. But yeah, I would just like to invite you all to I would just like to conclude this session and invite you all to keep an eye out for our upcoming webinars, which should touch upon various different issues relating to water and livelihoods. And yes, thank you everybody. Thank you all the participants for coming and joining. So yeah, that's it from my end.
Thanks a lot. Thank you, Urna, and thank you,
Thank you,
Priyanka
everyone.
and Ram.
Thank you so much, sir. Thank you, everyone.